Hello, this is Ms. DB, and in this video we're going to go over how to do some problems from the 11.6 assignment on simplifying radical expressions. So basically we're going to be simplifying square roots in this lesson. So a radical expression is just one that contains a radical, and we'll be using square roots. There's also cubed roots and fourth roots and so on, and they're all called radicals, but we'll be working with the square root today. In order to do that, you can either copy and paste this little image, or you can go to Insert, Symbols, and find a square root. Let's see, here's one here. It's only the first part of the square root. Or you can just write SQRT for square root. That works well when you're typing. So what we're going to do is make sure that our square root is simplified. So here's how we tell if it's simplified. If there are no perfect square factors other than 1, that's good. If it has no fractions, that's good. And there are no square roots in the denominator, then that's good. If it meets all three of those things, then we'll say that it is simplified. So here's an example of one that is not simplified, the square root of 50. That's not simplified, and the reason is for the first reason. It has perfect square factors. If you factor 50, you can factor that as 25 times 2, and 25 is a perfect square. So if you can factor the number or even the variables and get a perfect square, then it's not simplified. So in order to simplify the square root of 50, what we do is we rewrite it with its factors. So it's kind of like finding the greatest common factor or finding all the prime factors, in that you write what times what is equal to 50. If you can do that so that one of the factors is a perfect square, then even better. Once you know that 50 is the same as 25 times 2, then we can rewrite the square root of 50 as the square root of 25 times 2. And then there's a property that says that if you have the square root of a product, like the square root of 25 times 2, you can rewrite that as the square root of 25 times the square root of 2. Now we simplify the square root of 25, because what is the square root of 25? It's just 5, so the square root of 25 becomes 5. The square root of 2 cannot be simplified, so we just write that after the 5. This now is simplified because it has no perfect square factors other than 1. It has no fractions. There are no square roots in the denominator. So now it's good. And we will look at how to factor using these other rules as well. Do note that x squared is a perfect square because the square root of x squared is x, because x times x is x squared. So this one you would simplify by writing this as the square root of x squared times the square root of y, which then is x times the square root of y. So there are parts that you won't, there will be plenty of times where you'll still have a square root in your answer. And there are some times where all of the square roots will simplify, but usually there'll still be a root in your answer somewhere. All right, let's look at a couple more examples. This is an example where first, this is like if they had, let me get my pencil here, square root of 90, and then they already wrote it as the square root of 6 times the square root of 15. But when they wrote it as the square root of 6 times the square root of 15, neither of those are perfect squares, so it didn't help me out very much. So instead, I said, well, I can write that as the square root of 6 times the square root of 15, but that doesn't, I can't simplify either of those. Neither of those are perfect square. So instead, what I'm going to do is write that as a product of prime numbers. So 2 times 3, that's 6. 3 times 5, that's 15. So I could write this as 2 times 3 times 3 times 5. Now there's 2 3's. If there are 2 of the same number, that's a perfect square right there. So that's the square root of 9 right there. I could multiply it together if I wanted. Or when you see two numbers that are exactly the same, one of those numbers will get to go out front and the other one will get crossed off. So I'm going to be left with 3 times the square root of 2 times 5 is 10. Or we can do it the way they did it. They said, okay, I'll put these two together and then I'll put these two together. So 3 times 3, that's the square root of 9. And 2 times 5, that's 10. So I have the square root of 9 times the square root of 10, which is also the square root of 90. And the square root of 9 is a perfect square, which is 3. So there are times where you don't notice what the perfect square is the first time you write the factors, but you can work with it after that. You can either find other factors and find one that's a perfect square, or you can break it into a product of primes to help you find that. Here's another example of one that might look a little bit tricky. Let's do the square root of 150. So the square root of 150, let's say that I can't find, I do 15 times 10, but neither of those are a perfect square. So then I'm going to say, well, 15 is 3 times 5, and 10 is 5 times 2, and then I see the two 5s. So at that point, you can either use that to rewrite this as a different pair of factors, put the two 5s together and the 3 and 2 together, or you can say, oh, there's my perfect square, 5 times 5. That means that one of the 5s will come out front, the other one will get crossed off, and underneath the radical is the 3 and the 2 that's left. And the reason that that works is because the 5 times 5 is 25, so that's the square root of 25. And the 3 times 2 is 6, so that's the square root of 6. And the square root of 25 is 5, and the square root of 6 stays as the square root of 6. All right, so there's a couple different ways to go about finding or to simplifying a square root. So we're going to do some that have just numbers in them, and then we'll do some that have letters as well, variables as well, and then we'll also look at the quotient rule, what happens when we have a fraction. Let's look at number 3 because of that x squared, or x to the 4th. So first of all, let's rewrite 54 as a pair of factors. Let's see. So 54 is 9 times 6. So we'll start with that. So that's the square root of 9. Whoa, square root of 9 times 6. Why is it jumping all over the place here? And 54 is the same as 9 times 6. So write the square root of 9 times 6. And we still need to put the x to the 4th in there. Now we can break this into each square root of each separate part times each other. So we have the square root of 9 times the square root of 6 times the square root of x to the 4th. Now the square root of 9 is a perfect square, so we can just say that is 3, because 3 times 3 is 9. The square root of 6 cannot be simplified. It's done. We can't make that into any more perfect square factors. But the square root of x to the 4th, you might be a little confused about that part. If it is an even exponent, then you can take the square root of it. So the square root of x to the 2nd is just x, because x times x equals x squared. The square root of x to the 3rd can be rewritten as the square root of x squared times the square root of x. And the square root of x to the 2nd we know is just x, because we just did that one. So the answer to the square root of x to the 3rd would be x times the square root of x. We have x to the 4th, and the way you take the square root of that is you say, well, that's the same as the square root of x squared times the square root of x squared, because the square root of x squared times the square root of x squared would be the same as the square root of x to the 4th. And what is the square root of x squared? It's right here. It's 1. It's x. 1x. And the square root of x squared here is x. So we have x times x, which is x squared. No square root anymore because we took the square root of it and got x squared. And then we put the two parts that aren't under the radical together, write that in front, so 3x squared goes in front, and then we write the square root of 6. Now if you were typing this, let's see, I'm just going to type it over here. You would type 3x squared, you can use that, caret key, and then I'm going to write square root of 6. So I put the 6 in parentheses just to make sure you see that it is that's what we're taking the square root of. So 3x squared times the square root of 6 is how you would type that. And let's look at, we're going to come back to the ones that are looking like fractions, but let's look at 7, 8, 9, 10, 11, 12. Those are all just products here. So the square root of 72 is already started, and it's almost all done. All you have to do is fill in what is the square root of 36, because 72 equals 36 times 2, so that the square root of 72 is equal to the square root of 76, or 36, sorry, times the square root of 2, and then we simplified this because it's a perfect square. For 8, they already gave us a giant hint that 300 can be written as 100 times something. So you'll put that here. And it's okay if you can't fill in these numbers because you're typing. You can just type the answer below it. And then we take the square root of 100 because that's a perfect square and write what you get. And then if you can't simplify the second part, remember you can just write square root of whatever the number is there. And then in number 9, the square root of b squared is just b. And the square root of c squared is just c. So you're going to take the square root of each of those parts. They're both perfect squares. Just like the square root of x squared is x, the square root of b squared will be b, and the square root of c squared will be c. So you'll write your answer as just bc. Let's see, is there anything tricky in these ones? We did the square root of 90 already up here. So you can look back at that and see how to do the square root of 90 and check what your answer will be. And then there's some more down here. These are just some numbers, and then there's some with variables, so it's just more practice. We'll do one more. Let's do number 24. So the square root, I'm going to put the square root of 36 by itself. Now, this is a perfect square. You should recognize that 6 times 6 is equal to 36, so there's no reason to write that as two factors. Then I'm going to put the x to the 4th underneath its own radical, and I'll put the y to the 5th under its own radical. And then I'll start simplifying. Well, the square root of 36 is just 6. The square root of x to the 4th. Well, you could write that as the square root of x squared times the square root of x squared. Or you could say, well, it seems to be a pattern that if you have an even exponent and you take the square root of it, all you have to do is take half of that exponent. And that's true. So this is going to be 6x squared. Or you can break it into x squared times x squared, square root of both of those, and then the square root of x squared is x, and the square root of x squared is x. So we have x times x, which is x squared again. Now, y to the 5th, I'm going to rewrite that as the square root of y to the 4th times the square root of y, because y, that's the same as 1. And the square root of y to the 4th, just like the square root of x to the 4th is x squared, square root of y to the 4th is y squared. Now, the only square root we have left is the square root of y. That's the only one that could not be written as a perfect square and then simplified. So our whole answer would be 6x squared y squared times the square root of y. Okay, now I'd like to go back for a couple minutes and look at what happens if you have a division problem. There's, again, more than one way we can deal with this. One way is that we can write this as the square root of x to the 6th over the square root of 16, which is what I think they meant to do here, but it looks like the exact same thing twice. And then we'd simplify the top part, and we'd simplify the bottom part, and then see what we have. So the square root of 16, that's a perfect square, that's just 4. The square root of x to the 6th, we could write that as the square root of x squared, x squared, x squared, with square roots around each of them, because 2 plus 2 plus 2 is 6. And this would be x times x times x, that's x to the 3rd. Or you can say the exponent is an even number, and if we take the square root of it, we'll just be taking half of that. So that would be x to the 3rd. So this all simplifies to x to the 3rd over 4. So that's one way to look at if you have a fraction that is underneath the radical sign. The other thing that sometimes works is that you can simplify before you take the square roots. I don't see an example, but if you had like the square root of 100, I don't know, fourths, then you could do the division here first, simplify, and get the square root of 25, and then simplify that. So if you can, simplify before going ahead and doing more work than is needed. All right, so let's look at something like number 4, the square root of 7 over 81. Let's write this as the square root of 7 over the square root of 81, and then we'll simplify both the numerator and the denominator if possible. The square root of 7 cannot be simplified, so we just leave that. The square root of 81, though, is a perfect square. It's just 9, so our answer would be the square root of 7 over 9. Now let's say you're typing this. This is one of the assignments that's not so fun to type, but you could just write the square root of 7, so I'm just going to use the SQRT, then use the division sign, and then my denominator is 9. If there was a lot of stuff in the denominator, I could put it in parentheses to make sure that we knew that all of that was in the denominator, but if it's just one number, then you can just type that number. And let's see what else we could look at. Let's do 26. So in number 26, we're going to rewrite this as the square root. Actually, this one can be simplified. Let's simplify first, because 3 over 27 simplifies to 1/9. And b squared over b to the 4th simplifies to b squared in the denominator. Because there's 2 on the top and 4 on the bottom, that leaves 2 in the bottom. So this all simplifies to the square root of 1 over 9b squared. Now we'll rewrite this as the square root of 1 over the square root of 9. I'm going to write this as 2 square roots. The square root of 9 times the square root of b squared. The square root of 1 is 1. The square root of 9 is 3. The square root of b squared is just b. So this all simplifies to 1 over 3b. And if I was typing that, I would need to put the 3b in parentheses, because otherwise you wouldn't know that both parts were in the... Oh, I don't have square root anymore. I have 1 divided by 3b. I'd leave it like that. Okay, one more type of problem to look at, and there's only a couple like this on the worksheet. But if you have something that can be factored, then factor it, and if it's a perfect square, then you can take the square root of it. I thought I saw one like this. Oh, number 16. 16 is x plus 8 squared. And if you take the square root of anything that is squared, then all you have is x plus 8 for your answer. And that's similar to number 18. If we can write this as something times something, 2 factors, and they both happen to be the same thing, which it looks like they will be, because the factors of 16 is 4 and 4, and that adds together to be 8. So this could be written as the square root of x plus 4 squared. And if you take the square root of something that is being squared, then you're just left with this, because square root undoes squaring. They're opposite inverse operations, so they undo each other. So the answer would just be x plus 4. All right, well, I think that will give you a good start. Please let me know if you have any questions or if you get stuck on any of these, and I'll help you out. Thanks a lot and have a great day.